Hello everybody, welcome back to Virtual School Physics is Fun again. This is Puan Liao. So we will continue with wave concepts part 3. Alright, as we have learned, when a system oscillates, wave is produced. Okay, so two very simple example of a system that produces wave is the simple pendulum and the mass on a spring. Okay, so let's look at the mass on the spring. This is a spring and the mass is hung on it and the spring is oscillating. Okay, so before we stretch the spring down at the original position here, this is called the equilibrium position. Okay, so from the equilibrium position, we can stretch the string down and let it go up, and then it comes back to the original position, and then it goes to the maximum stretching again. So this is what we call the equilibrium position. For a simple pendulum, it is the same thing. Yeah. So the pendulum, before we start to oscillate, so position O, this is called the equilibrium position. Therefore, equilibrium position is the original position of a particle before a system oscillates. So we name it as O. Whereas displacement is the distance of a point from the equilibrium position. Okay, for example, if we displace the pendulum until A here, so the distance AO is what we call the displacement. For a mass on the spring, O is the equilibrium position. If we stretch the spring to B before we let go, so OA, OB is called the displacement. And of course, if we compress a spring from the equilibrium position, we compress it to A before we let go. So the distance OA is also the displacement. All right, so here, this red line shows the equilibrium position. All right, now, let's take a look at these two blue dots. What can you say about these two blue dots? Let's look at their movement. Do you think they are moving in the same direction? Yes, both. If they both one move up, the other one moves up as well. And not only that, both of them have the same displacement from the equilibrium position. Therefore, with these two characteristics, points that are having same displacement and moving in the same direction, these 2 points is called in phase. Points in a wave that are in phase will have same displacement and moving in the same direction. So these two blue dots are said to be moving in phase. Let's look at this graph here. I have marked points like A, B, C, D until O. Can you name points that are in phase? Let's say A. Which points that are in phase with A? So you can see A, E, I, M. So A, E, I, M are points that are in phase because A, the displacement is 0, so is E, so is I, and so is M. And not only that, A is on the way upwards, E too upwards, I also going upwards, M is also on the way upwards. So these 4 points are in phase. What about C? C, what is the displacement of C? Yes, the displacement of C is 0. But what is the direction of a particle that is at C? This particle is on its way down. So is it the same direction as the particle at A? Particle at A is on the way up. C is on the way down. So is A and C in phase? No, isn't it? Right? Because even though both have got the same displacement, but they do not have the same direction. A is on the way up, C is on the way down. So A and C are not in phase. But C, G, K, and O are in phase. Okay? B, F, J, and N, they are in phase because B, F, J, and N, they have the same displacement, which is this, this, and this, and they are on the way down, 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 and down. So B, F, J, and N are said to be in phase. Same thing as D, H, and L. So these 3 points are in phase. Let's look at another concept of wave that is called wavefront. What is a wavefront? A wavefront is a line or a plane on which the vibration of every point on the line or on the plane are in phase. Okay, let's look at this. So these red waves, this is the crest, 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 crest. These are all crests. Okay, so we have seen just now from the previous slide that crests are in phase. So when I join up all the crests here, so I have a line, and this line is called a wavefront. So this is also another wavefront. So is this. Okay, if these lines, these lines, and these lines, and these lines all join up, so I will have a plane, I will have a surface. Therefore, a wavefront can be a line or a plane with all the points in phase, all in them. Okay, let's look at these two pictures. Okay, let's look at this plane wave first. This plane wave. So this is the crest, crest, crest. All the crests we join up, we get one plane wave, one wavefront. This is another set of crests. So this is another wavefront. This is also another wavefront. So these wavefronts, they are all lines. Yeah. So all these lines wavefront is called plane waves. As compared to this water wave, these are the crests, or the crests, remember, the peak of the mountain, or we join up, so we form a circle. It's not like a line like this one, but it is a circle. So is these are all crests. So this set of crests, when I join up, I get another circle. So these are called the circular waves. Okay, so water wave, I can have plane wave, I can have circular wave. So how can I produce a plane wave? Plane water wave. Yeah, if I use a piece of wood, I oscillate, I touch the surface of the water, so plane wave will be produced, plane water waves. But if I touch the surface of the water with my thumb, I oscillate my thumb up and down, so I will produce circular water wave. Okay, now wavefront and the direction of the wave is always perpendicular. So these purple lines show the direction of the propagation of the wave. The blue lines are the wavefront. So you see the circular wave, in a circular wave, the direction of the wave and the wavefront 90-degree. And of course the plane wave too. Okay, the wavefront and the direction of the wave, they are 90-degree to one another. Next one, amplitude. Symbol of amplitude is A. What is the meaning of amplitude? Amplitude is maximum displacement from the equilibrium. It's just a distance. It's a distance which is measured from the equilibrium position. Okay, so maximum amplitude, maximum displacement is called amplitude. Okay, this is a displacement, this is also a displacement, this is also a displacement. Imagine the particles is moving upwards until here. So this is a maximum displacement before it comes down, right? Before the displacement decreases. So this is called the amplitude. Same thing here, this is amplitude. So maximum amplitude, maximum displacement from the equilibrium position is called amplitude. Okay, amplitude. Look at these two graphs. What can you say about these two graphs in terms of amplitude? So this is the equilibrium position. So this is the amplitude. Compared to this is the equilibrium position, and this is the amplitude. So you see the difference? This is low amplitude. This is high amplitude.